So in this video, we're going to talk about geometric series, and it's important to remember the vocabulary for series is that series is a sum of a sequence uh, between two identified terms. It could just be between terms 1 and 2. It could be, as you saw earlier, the sum of A1 through A5. So the difference is, with geometric, we might see something where we're multiplying by 3 for each term. And what happens is as I keep going, we continue to get larger numbers, and those larger numbers would then be all added together. So the sum of these 5 terms would be, instead of just put a comma here, we would add them all up. And as you can see, that can get kind of, even with this simple one where I took 2 and multiplied it times 3 and then by 3, by 3, by 3, you start to get pretty large numbers, and that's why we have formulas. So S of n is the formula used to add all these terms together. And it's also known as the final sum. So it's the formula, but it also represents the final sum of the formula. Remember, n in math means last. So there's also this Greek letter sigma, which can be used with geometric series. It's the universal letter used for math and summation. So that letter is just a way to basically tell people to add up an equation inside. There is, of course, an an in here, which is the formula in this case for geometric. It could be arithmetic. And we start at whatever term. The basic formula starts at 1 and then goes to n. But, this could be 3 to 7, as we learned when we did the arithmetic problem. Same thing with geometric. So the geometric equations, the first one is for something called a finite sum. Finite means it ends. It has an ending value. Which is interesting. So this one will say we're going to add a distinct amount, like S of 10 or S of 20 or even S of 1,000. Well, in geometric, because of that convergent, non-convergent, there's actually a second formula that we'll talk about that's for infinite sums. So if you have a finite sum, the formula is take A1 and multiply this ratio of 1 minus r to the n. Notice it's not n minus 1, it's 1 minus r to the n. Divided by 1 minus r. This does not simplify. You cannot cancel this because this is actually an n number of these. So that wouldn't work because we don't know how many there are. That would only cancel, of course, if it was to the first power, which why would you do that? That's just one term. So don't cancel or reduce this. Just plug numbers into it. A couple of important notes. There's no an in this formula. Remember, when we did arithmetic, both formulas had an's. So there's no need to know the final term to find the final sum, which is incredibly interesting. There's only one formula. Finite sums have one formula. There is a hidden parentheses around the numerator and denominator, so it's very important to understand, especially when you're typing this into calculators, that there's actually a parentheses here and down here, which we learned when we did rational functions. Very important for when you type things into calculators. The r also has a hidden parentheses if it's negative or a fraction, that's really going to matter. So we really need to make sure we also encapsulate this in a parentheses. If it's ever something that isn't just an integer. If it's 5, you're good. A positive integer, you're fine. But if it's -5, you're going to have to put this in a parentheses, or else the calculator will interpret those two negatives as a positive, and r is not, right? If we said it's -5. Also, you need to put it in parentheses if there is a fraction. All right, so as I mentioned a second ago, there's another formula for infinite sum. And as you've seen this previously, this is the terminology for convergent, right? Otherwise known as a sequence that has, if we're talking about exponential, it would be a decay sequence. So if it's convergent, we have a new formula. And it's actually the same as this formula up here. But what's happened is that in a convergent sequence, this part will go to 0. It'll go to 0, leaving you with 1 over r minus 1, and 1 times a1 is this formula. So they're actually the same formula with one term eliminated. We'll talk more about why that goes to 0 when we look at problems that involve the infinite sum. So note, this formula is the same formula as the finite sum. As n goes to infinity, rn goes to 0. There is a hidden parentheses again, but it's, it is around this and around this. Why is it important? Well, we obviously understand why we need to simplify this, but you might think, well, what if that's just a number? Well, if r is between 0 and 1, that's always a fraction. And that's why it's important to remember that there's actually a parentheses there. And the R also can have a parentheses as well, because what if it's a fraction? So remember that we're dealing with things that are between 0 and 1. A1 could be a fraction, could be an integer. Even when it is an integer, you need to turn it into a fraction because R will always be a fraction. So just be careful. Understand that there are two formulas. They're actually the same formula if I cancel this out. And it's just very important to remember those things. But when we actually do these problems, they're actually, in my opinion, a little simpler than arithmetic because we just rely on the calculator to do this very complicated parentheses. Just be careful where you put all of your parentheses.